Look up on a clear night. The sky is mostly black, dotted with pinpricks of light. But here's a strange thought. If the universe had an infinite number of stars, shining forever, why is the night dark at all? Why isn't the sky as bright as the surface of a star? This puzzled astronomers for centuries. Today we call it Olbers Paradox, and its answer tells us something deep about space, time, and the history of the cosmos. In the 19th century, the German astronomer Heinrich Olbers framed a simple question. In an eternal, infinite static universe filled uniformly with stars, every line of sight should end on a star. If that were true, the whole sky would glow like the surface of the sun. Yet it does not. The night is mostly dark. That contradiction is Olbers' paradox. It's not a math trick. It's a clear, intuitive clash between how people thought the universe was and what we actually see. Why do people expect a bright sky? Imagine concentric spherical shells of stars around Earth. Each shell is larger, but contains more stars. The increase in the number of stars exactly compensates for the dimming from distance. So every shell contributes roughly the same amount of light. Add up infinitely many shells, and the total light would diverge. The sky should be blinded. That is the simple classical argument, and it looks convincing until we check the assumptions behind it. First, the universe is not eternal in the past. It began about 13.8 billion years ago in the Big Bang. Light travels at a finite speed, so we can only see objects whose light has had time to reach us. That region is the observable universe. There simply aren't infinite shells whose light can already arrive. The countable layers of stars are limited by time. If you live at a moment in cosmic history, you can only see a finite portion of the whole universe. Second, space itself is expanding. As light travels across expanding space, its wavelength stretches, a process called redshift. Stretch a visible photon enough, and it falls into the infrared, then microwave, then radio. The photon's energy decreases as its wavelength grows. So even light that left a star long ago may have been stretched into wavelengths we can't see, and its energy contribution to visible brightness becomes negligible. Expansion dilutes starlight and prevents the sky from piling up into a blinding glow. Third, stars aren't eternal light bulbs that burn forever. They form from gas, live through life cycles, and die. The number of luminous stars at any cosmic epoch is shaped by the history of star formation. Early on, there were fewer stars. Later, star formation changes. Because the luminous population evolves, the assumption of a uniform, unchanging sea of stars breaks down. Some early ideas suggested interstellar dust could block starlight and keep the sky dark. But dust doesn't destroy energy. It absorbs starlight and heats up, then re-radiates that energy, mostly in the infrared. Over time, the absorbed starlight would still show up as background glow. So absorption alone cannot explain the darkness of the night in a truly eternal, static universe. When we look carefully, the night sky does carry background light, but it's tiny in visible wavelengths. Instead, much of the radiation from the early universe shows up as the cosmic microwave background, a faint, uniform glow at microwave frequencies, a direct remnant of the hot early phase. Astronomers also measure an extragalactic background light across infrared, optical, and ultraviolet bands, but it is far weaker than the hypothetical blinding sky of a static infinite universe. The combination of finite age, expansion, and evolving sources matches what we measure. Olbers Paradox is more than a curiosity. It's a diagnostic tool. The darkness of the night forced us to question simple assumptions and led, in part, to the realization that the universe had a beginning and that space itself is dynamic. The fact that the sky is mostly dark is evidence for a finite age, expanding cosmos where light is stretched and diluted across vast distances. So when you stare at the night and see black between the stars, you're looking at the fingerprint of cosmic history, the imprint of a universe that began, expanded, and continues to change.